This video is going to focus on some of the major seafloor features that we see along our deep oceans. One of the things that we see around our active continental margins are our deep sea or our deep ocean trenches. And these form along subduction zones, where we have an oceanic plate that is being subducted or pushed back underneath either a continental or another oceanic plate. And because this is where we have active plate tectonics, so most of our deep ocean trenches are found along the Pacific Ocean. And these deep ocean trenches are the deepest areas of our oceans. You might have heard about the Mariana Trench before. This is the deepest location on our entire planet. The Mariana Trench is twice as deep as Mount Everest is tall. So they are incredibly deep areas of our oceans. But they're also really long and relatively narrow. They're not very wide at all. And the reason why is that this is a subduction zone. It's found on a very narrow, active continental margin. But when we look closely at these deep ocean trenches, we generally find either volcanic island arcs or continental volcanic arcs on them. We see chains of volcanoes, and we're going to term them one of these two, depending on whether they're forming on top of a continent or on top of an ocean. If they're forming in our ocean, we call these volcanic island arcs. They happen when an oceanic plate subducts underneath another oceanic plate. But if we have an oceanic plate subducting underneath a continent, the volcanoes will form on the continent, leading to continental volcanic arcs instead. There are two more features that we need to discuss, though, and one of these is called an abyssal plain. And the word abyssal just means incredibly deep. Plain means very flat. So these abyssal plains are some of the deepest areas, not as deep as our deep sea trenches, but still very deep areas of our oceans that are probably the most level surfaces anywhere on our planet. And this is because we have really thick layers of sediment that's been accumulating in our abyssal plain. So think about all of the dust that might be accumulating on top of like your TV stand or coffee table. It forms really nice, completely flat layers because the dust is very slowly settling on top of your TV stand out of the air. And with these abyssal plains, we see that the sediment is settling out of the water, and it's going to form really flat, almost perfectly flat layers of our seafloor that we call our abyssal plains. And these abyssal plains are found in every single one of our oceans. It doesn't matter if it's active or passive, it's found everywhere. But we'll also see what are called seamounts. And a seamount just means it's an undersea mountain. These are isolated volcanoes, and a lot of them form near our mid-ocean ridges, where we have that divergent boundary, where we have a high elevation of our seafloor because of that new hot crust that's forming. But with our seamounts, if they grow tall enough and they go above the surface of our oceans, now we call them an island. It's just a rock that's above our seafloor. Our mid-ocean ridges are found along those divergent boundaries inside of our ocean, where we have two plates that are separating, and we're creating new, really hot crust between them as they separate. And because this crust is new, it's really hot, it expands. So it causes the spreading center of these divergent boundaries to elevate above the seafloor. It's going to kind of look like there's a mountain just going literally through the middle of each of our oceans. And this map makes these mid-ocean ridges look like they're fairly small. But in fact, this is the longest feature on Earth's entire surface. Remember that we're a water planet. We're mostly oceans. So we see that 23%, just about a quarter of Earth's surface, is covered by these mid-ocean ridges. They're, in fact, not thin lines found in our oceans, but generally they're hundreds of miles wide. And we see that in length, they cover over 40,000 miles of our oceans. And they go through every single one of our major oceans as well. Regardless of which ridge system we're looking at, we see that they all have a really elevated middle. That spreading center is going to be at a higher elevation than the rest of the seafloor due to the fact that it's newly formed crust. It just turned from magma into a solid. It's still hot, so it's going to expand out due to that heat, giving it a higher elevation than the rest of the seafloor. But because we have solid rock that's trying to expand, here we're going to have a ton of faulting develop, where the rocks are going to break and move in relation to one another. But because we're dealing with magma coming towards the surface, these mid-ocean ridges also have tons of different volcanic structures around them as well. And while we have mid-ocean ridges in every single one of our oceans, the Mid-Atlantic Ridge is the best studied. We know more about the Mid-Atlantic Ridge than any other ridge system on our planet. Even though at our mid-ocean ridge we see that it's elevated, at the very center of that divergent boundary where the spreading center is, a rift valley forms. And a rift valley is just going to be a really deep, broken area in the very middle of this divergent boundary where it's being rifted or broken into two. But I want to focus again on why we see that our mid-ocean ridges have a higher elevation than the rest of our seafloor. And because I'm going back and re-emphasizing this, you should probably know it for your quizzes and for your exam. The reason why our mid-ocean ridges are elevated, they're higher than the rest of the seafloor, is due to the fact that they are newly formed crust. This newly formed crust just turned from a liquid magma into a solid rock, so it's still really hot. And I don't know about y'all, but when I get really hot, I like to expand out. If I'm trying to sleep in a warm room, I'm going to take up the entire bed. I'm going to expand my body to take up more surface area so it cools down faster. And rocks do the same thing. When they're new and they're really hot, they expand. So when they expand, they just expand into a higher elevation. They get taller above the seafloor. But as we move away from this rift valley and the spreading center, those rocks will have aged some. They're not newly formed anymore. As they get older, they're going to get colder. And as they get colder, they're going to contract into a smaller space, leading the edges far away from our mid-ocean ridge to be at a lower elevation than that newly formed center at our rift valley and spreading center.